Sequences. In today's lesson, we will be looking at the nth term and arithmetic sequences. So let's have a look at some sequences and see what a sequence actually is. So my first example here would be 2, 4, 6, 8. Okay, let's work out the next few terms in this sequence. Now, a sequence is a pattern. It's a pattern of numbers. There's a pattern to it. Something's happening with this list of numbers, and it follows into a pattern so that we can work out the next few terms in this pattern, you could say. So let's have a look. We know that here we are adding 2, adding 2, and adding 2. Okay, so an arithmetic sequence, you add or subtract to get to the next term. Okay, that's what an arithmetic sequence is. If you are multiplying or dividing, then that's not an arithmetic sequence, that would be a geometric sequence. Okay, so we know we are adding 2 each time, so we know that the next number would be 10 because 8 add 2 is 10, and the next number would be 12. Okay, let's have a look at another example then. Okay, let's have a look at something similar. 9, 14, 19. Okay, there is a pattern here. What's the pattern? Well, we are adding 5 here, and then we are adding 5 again. So we know the next one, if we add 5, we get 24, and then we add 5 again, we get 29. Okay, so there's a pattern here. Let's have a look at another example. Okay, let's have a look at 13, 11, 9. Okay, so what's happening here? Well, this time we are subtracting 2 each time. Yeah, 13 take away 2 is 11, 11 take away 2 is 9. So that means the next two terms, well, 9 take away 2 is 7, and 7 take away 2 is 5. Okay, have a look at another example. Okay, this time let's have a look at, let's do 16, 25, actually, let's go back, let's do 1, 4, 9, and 16, that's better. Okay, so we've got number 1, then we've got 4, then we've got 9, then we've got 16. This is just a pattern of sequences this time. So let's just have a look. Sometimes in the exams, if it's a 1-mark question, you might be asked to work out the next 2 terms. So it might not be adding and subtracting or multiplying and dividing. It might be something like this. So let's just have a look. Well, how do you get from 1 to 4? You add 3, don't you? Well, 4 to 9, you are adding 5. And then from 16 to 9, you are adding 7. Okay. Well, you could argue the next one you might have to add, let's say they're all odd numbers, isn't it? It's 3, 5, 7, and then next one would be 9. But actually, look, it doesn't start from the odd number, the first odd number, does it? Which is 1. So we can't add on 9. But what this is these are square numbers, because 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared would be 29, and 6 squared would be 36. So you might have a sequence like this, which is to do with square numbers, and you might have to work out the next few terms. Okay, right, let's have a look at actually working out the nth term then. Right, let's take an example. We've got 2, 4, 6, 8, 10, and so on. Okay, this is an arithmetic sequence. Why? Because what's the pattern? What's happening? I am adding 2 each time. And because I'm adding 2 each time, it's an arithmetic sequence. Well, how do you work out the nth term? And then I'll go on to explain what the nth term is afterwards. Well, have a look. The difference between each term is 2. So we're going to say this is a 2n. The nth term is 2n. Well, let's check if we need to add anything on at the end or not. That's my first number in my sequence. That's my second number, my third number, my fourth number, and my fifth number. Okay, well, I'm saying that my sequence is 2n. Well, what I do is I replace the n means the any term in your sequence, okay? Any term in your sequence. Well, if we're looking at the first number in the sequence, I'm going to replace n with 1. Well, what does 2n mean in maths? 2n actually means 2 times n, doesn't it? And n means any number in sequence. Okay, if I want the first number in my sequence, I'm going to do 2 times 1, which is 2. And is the first number in my sequence 2? Yes, it is. If I want the second number in my sequence, I'm going to do 2 times, well, I want my second number, so 2, which is 4. Is the second number 4? Yeah. Then I want my third number. Okay, I'm going to do 2 times, well, my n here is 3 because that's the third number. That's the number that I want, which is 6. Is this third number 6? Yes, it is. So my nth term is 2n. Okay. And using this, we can work out lots of different things, which we'll get onto later on. Let's have a look at another example then. Okay. And you can also see here actually that this is the 2 times table, isn't it? 2, 4, 6, 8, 10, 2 times table, so 2n. Okay, let's have a look at another example similar to this one. 3, 6, 9, 12, 15, and so on. Okay, right, what's the difference between each term? It's 3, 3, 3, 3. Okay, right, that's my first number in my pattern, my second number, my third number, my fourth number, and my fifth number. Okay, because the difference between each term is 3, I'm adding 3 each time. My pattern is 3n. Remember, n means any number in my sequence. So we're going to double check. If I want the first number in my sequence, well, 3n means 3 times n. So 3 times 1, because I want my first number, which is 3. And yes, my first number is 3. If I wanted my second number, I would do 3 times 2, because any number, the number I want in my sequence is the second number, which is 6. Yes, it is, and therefore it is correct. This sequence, the nth term, is 3n, and we know that because it's a 3 times table. Okay, now, what if we had this one? Some of them are quite easy to spot. 9, 18, 27, 36, and 45, and so on. Okay, well, what's the difference between the numbers this time? Well, I'm adding 9 here. Add 9, add 9, and add 9. So adding 9 is 9n, and we know this because what is it? It's the 9 times table. Okay, if we had 4, 8, 12, 16, 20, what times table is this? And we know it's all adding 4 each time, don't we? What times table is this? It's a 4 times table, so it's just 4n. Okay, let's have a look at something slightly different then. Let's have a look at 3, 5, 7, 9, and 11. Okay, so what we're doing this time, each time, I'm adding 2, adding 2, adding 2, and adding 2. Okay, so I'm going to say my sequence is 2n. However, that's incorrect because that's not the 2 times table, is it? It's not 2, 4, 6, 8, 10. So we've got to do some other work with this now. That's my first number in my pattern. That's my second number. That's my third number. That's my fourth number. And that's my fifth number. Well, let's have a look. My first number in my pattern here. So if I'm just going to write that there, my first number in my pattern would be 2 times 1, which is 2. But my first number is not 2, it's 3. How do I get from 2 to 3? I've got 3 here. Well, I need to add 1. My second number in the 2 times table would be 4, wouldn't it? 2 times 2 is 4. But my second number is not 4. It's 5. Well, how do I get from 4 to 5? I have to add 1. Let's check the third one as well. The third number in the 2 times table would be 6, but my number's not 6, the third number in my pattern, it's 7. How do I get from 6 to 7? I add 1. So this sequence is the 2 times table, and you are adding 1 each time. Okay, and we can check that because let's check the fourth number here. The fourth number in the 2 times table would be 8, but I've got to add 1 to get 9, and that's correct. The fourth number is 9. Okay, have a look at something different now again. Let's do 1, 3, 5, 7, 9, so on. So again, let's work out the difference. From 1 to 3, I add 2. 3 to 5, add 2. 5 to 7, add 2. 7 to 9, add 2. So again, this sequence is a 2n sequence. But that's not all, because that's not the 2 times table, is it? 2n means the 2 times table. So the first number in the 2 times table would be 2, but my first number is 1. How do I get from 2 to 1? Well, I subtract 1. The second number in the 2 times table would be 2 times 2, which is 4, but my second number is 3. How do I get from 4 to 3? I'm subtracting 1. The third number in the 2 times table would be 6, but my third number is 5. How do I end up with 6 to 5? I subtract 1. So my sequence is 2n subtract 1. Okay, and we can check that because we've done the third term. The fourth term, well, the fourth number in the 2 times table is 8. If I subtract 1, I get 7. And look, my fourth number is 7. Let's have a look at a different example. Five, 9, 13, 17, 21. Okay, how do I get from each term? I'm adding 4 each time, aren't I? That's add 4, add 4, add 4, and add 4. Okay, so if I'm adding 4 each time, it's the 4n sequence. That means the 4 times table. However, those numbers there aren't the 4 times table, are they? So what you could do, let's do it a slightly different way, okay? So let's do it in a bit of a table if that is better for you rather than the what we did above. So let's do 4, 8, 12, 16. They're the numbers in the 4 times table, aren't they? But my numbers are these numbers here. So I've got 5, 9, 13, and 17. And we can see here, we are adding 1, adding 1, adding 1, and adding 1. Okay, so it's the 4 times table. Add 1. Maybe that is a better way of doing it if you want to write it like this, or you can do it by doing it the way that I did before. Let's have a look at another example then. Again, let's have a look at 3, 7, 11, 15, and so on. Again, what's the difference between these numbers? I am adding 4, adding 4, adding 4. Okay, so it's the 4n, 4 times table, but that's not the 4 times table, is it? So I'm going to write the 4 times table out. It's 4, 8, 12. I'm going to write the first 3. But my pattern is 3, 7, 11. Well, how do I get from 4 to 3? Minus 1. 8 to 7, minus 1. 12 to 11, minus 1. So it's a 4 times table. Subtract 1 each time. Okay. Let's have a look at another one then. Let's have a look at 11, 17, 23, and 29. Okay, how do we get from each number this time? 11 to 17 is add 6. That is also add 6, and that's also add 6. So this time we're saying it's the 6 times table, so 6n. Is that the 6 times table? No, it isn't. So let's write the 6 times table. Just write the first 3 numbers out. So we've got 6, 12, and 18. But the numbers in my sequence are, the first number is 11, the second number is 17, and the third number is 23. Okay, well, how do I get to 6 to 11? Add 5. 12 to 17, add 5. 18 to 23, add 5. So it is 6n, add 5 as the sequence. Okay, rightio. Let's have a look at a different example, something slightly different. Let's do this time 12, 10, 8, and 6, and so on. Okay, well, how do I get from 12 to 10? I subtract 2. 10 to 8, subtract 2. 8 to 6, subtract 2. So look, this is different now from the other examples. All the other differences were positive, weren't they, above? They were all positive. This time we have got a negative. So what I'm going to do is, my sequence is minus 2n. It's a negative 2n. Right. That's not the minus 2 times table. If it's minus 2n, that means it's the minus 2 times table. So let's write down the first few numbers in the minus 2 times table. First number in the minus 2 times table is minus 2. Second number is minus 4. Third number is minus 6. However, my numbers are 12, 10, and 8. Well, how do I get from minus 2 to 12? I have to add 14. How do I get from minus 4 to 10? Again, I have to add 14. And from minus 6 to 8, I have to add 14 again. So my sequence is minus 2n, add 14. Okay, so minus 2 times table, but I have to add 14 onto it. Let's have a look at another negative example then. Let's do this time 10, 7, 4, and 1, and so on. Okay, how do I get from 10 to 7? I subtract 3. 7 to 4, subtract 3. 4 to 1, subtract 3. Because it's subtract 3, my sequence is minus 3n. That's not the minus 3 times table though, is it? So let's write down the minus 3 times table. Minus 3, minus 6, minus 9. But my numbers are 10, 7, and 4. Well, how do I get from minus 3 to 10? I have to add 13, don't I? Minus 6 to 7 is also add 13. And minus 9 to 4 is also add 13. Make sure you check these and you just don't guess them from the top of your head. So my sequence is minus 3n, add 13 each time. Okay. Let's look at another one like this then. Let's have a look at this one. 4, 0, minus 4, and minus 8. Okay, how do you get from 4 to 0? I subtract 4. 0 to minus 4, subtract 4. 4 to minus 8, subtract 4. So it's the minus 4n times table. Is that the minus 4 times table? Let's have a look. Minus 4, minus 8, and minus 12. But my numbers are 4, 0, minus 4. Okay, how do I get from minus 4 to 4? I have to add 8, don't I? Minus 8 to 0, I have to add 8. And minus 12 to minus 4, I have to add 8. So it's the minus 4 times table, add 8 each time. Okay. Let's have a look at another example. Minus 2, minus 4, minus 6, minus 8. Okay. How do I get from minus 2 to minus 4? Subtract 2. Minus 4 to minus 6, subtract 2. Minus 6 to minus 8, subtract 2. This is the minus 2n times table. Well, I can see that's the minus 2 times table because the first number in the minus 2 times table is minus 2. Second number is minus 4. Third number is minus 6. Well, my first number is minus 2. Second number is minus 4. Third number is minus 6. Look, you don't have to do anything. Add 0. Add 0. Add 0. Okay, so it stays as it is. It's the minus 2n times table. Okay, so that's how you work out the nth term of an arithmetic sequence. You can either do it as a table like here or above if you wanted to list down the numbers like we did here. What would the first number be and how to get to it, second number be and third number be? It's entirely up to you, but this is how you work out the nth term in an arithmetic sequence. Okay, thank you for watching.